Hello and welcome back. So let us try to understand what is multi-label classification in this session by using KNN algorithm. So we have understood KNN algorithm in the previous session. We are going to use programmatically how to implement a model using KNN algorithm and how to choose K and all the theoretical stuff we explained in the previous session. So what is multi-label classification? First you need to understand. Multi-label classification is generalization of a binary class classification. As you remember, the binary class classification problem will have the target variable with two categories, either yes or no, one or zero, or true or false. So in multi-label classification, if you have more number of y variables, in binary class classification, we had only one column, one y variable, and only two classes. But in multi-label classification, you will have more y variables, y1, y2, y3, y4, like that. And in each column, you will have two categories only, either 0 or 1. So let us try to look at a data set here and understand more clearly. This is an emotions data set which actually tries to take some musical instruments readings and tries to understand or predict what is the emotion involved in there. So if we are looking at 5 records here. The first record actually belongs to happy, pleasant, happy, pleased, and relaxing, calm. So the music has got 72 attributes, right? From here till here there are 72 attributes. Each attribute has got some reading, and the particular music is being flagged as two categories: happy, pleased, and happy, relaxing, calm. So here if you see, there are 6 y variables. When you pass one record, right, if a new music is played, you record it and you take the numbers out of it and pass it to the model. The model need to predict 5 labels, 6 labels here: surprised, pleased, calm, still, lonely, aggressive, right? So it need to predict 6 flags, and each flag has got each label has got two categories, either 0 or 1. So these kinds of problems are called as multi-label classification problems, and KNN algorithm can handle multi-label classification. So I imported all the necessary modules here and imported the data set, and then looked at the columns, and then splitted the data into x and y, x emotion and y emotion. So I have taken from all the rows from beginning till -6. That means till last from last record to 6 records. Okay, so those are all input variables, and then from -6 till end columns, they are output variables. So how many rows are there in this particular data set? 593 rows and 78 columns, out of which 6 columns are y variables. 6 y variables are there in this particular data set. Each y variable has got either 0 or 1. This problem is called as multi-label classification. So I divided the data into x-train and x-train and x-test using train test split. The train test split method will actually do the data set, the split, in a stratified fashion. Stratified sampling we call it as. It takes y variable as the stratifying column and makes the data into groups. So we have taken 10% into test set and 90% into train set, because data set is small, and we applied standard scaling, because before we apply KNN algorithm we should standardize the data, right? Rather, the KNN algorithm will give more importance to the columns which have got big numbers like these, right, and less importance to the columns which have got small numbers like these. We understood this in previous session. When you are calculating Euclidean distance, the outcome is mostly representing the numbers which are big, the differences between the numbers which are big. So to make the data set equally important, or make the columns equally important, we need to do some kind of scaling. In our theory we did divide by maximum, but in here we are doing standard scaling. Standard scaling means calculating z-score of each value, right? So So I have taken the standard scalar and then said fit transform. When I say fit, it calculates the means of each columns. If we have 72 columns in X, it will calculate 72 means and 72 standard deviations. Using the each column's mean and standard deviation, it is going to calculate standardized values of each column, normalized values of each cell. When you say transform, it's going to calculate the z-scores of each value and then replace it into the data set itself. So we have standardized the data. Now I have taken a k nearest neighbors, k neighbors classifier from neighbors module, k neighbors classifier from neighbors module, and then specified n neighbors is equal to 3. Just for experimental purposes I have taken k. Now n neighbors is equal to 3. This is k. In our k nearest neighbors, we need to specify the k. How many number of neighbors the algorithm should be looking into should be specified by the data scientist. So I specified the n neighbors is equal to 3. That means a new record is passed. If it need to make prediction, it will calculate the distances between that new record and all the 500 and whatever number of records, and then look at the 3 closest records and the target variables and make the decision. So here I specified 3 and then fitted the model, right? Created the object here and fitted the model. Now it understood, right? When you fit, it is just going to save the data into memory. That's it. Now you say predict. This is when it is taking all the records from the train set and trying to calculate distances between all the train set records. So if you have 500 records, 500 into 500, 25,000 calculations it will do for each record to find closest nearest neighbors, and based on the nearest neighbors it made predictions. So using F1 score method, we are actually calculating the F1 score here. So average is equal to weighted you should give, because the problem is of multi-label. You should definitely use weighted or micro or macro. If you don't specify these, right, it will throw error saying that it needs a POS label. Okay, so you need to specify some mechanism there. It is actually trying to calculate the average F1 score of all the different labels there and trying to calculate the F1 score. So we have got F1 score there 81%, but this is not the end of it, because we just built a model using train set and looked at the train set F1 score. It is 81%, but there is no guarantee that it will give good accuracy on the test set, and we did not choose the best k here. Randomly I gave 3, but it is not we don't know whether 3 neighbors is right or not. So we need to actually do a learning curve like this and find out the best k. To find the best k or choose the best k, what I did is I took the error into one list and k neighbors, the k value into one list, and then I am looping through by taking 3 neighbors, 5 neighbors, 7 neighbors till 21. So it's going to take till 19 only. This last value it is not going to consider range, right? So first it will start with 3, add 2, 5, add 2, 7, like that. It took 3. It created the k nearest neighbors object. Then using cross-val score, we are passing this model and passing xtrain and the xtrain labels and said CV is equal to 10. So if you say CV is equal to 10, it is going to split your data set into 10 parts and take first part aside and take the rest of the 9, build a model, test it on the first part, second part aside, rest 9, build a model, test it with the second part, third part, like that it is going to do. So with k is equal to 3, it's going to build 10 models and take the average, and that's going to be the F1 score. On the, it is like testing it on test set, right? So we have got the average F1 score. F1 score generally shows you the accuracy, it is not the error. So we are interested in knowing error, so I actually subtracted that accuracy from the 1. Okay, the accuracy from 1. Scores I have got, because cross-val score method I used, so I will get 10 scores, and I took the mean and subtracted it from 1 so that I will get the error. So F1 score is the accuracy, 1 minus F1 score is the error. So every time I get the error, I am saving it into the list. So like that I saved the k and the error in 2 lists and used those 2 lists to do the learning curve. when I did this learning curve, I understood that at k is equal to 9, I have got the least error. It is like 33% error. So the model will work well at k is equal to 9 on train set and test set both. Let us try to see that. I took k neighbors 9 and created an object, then fitted a model, and then made prediction, and then calculated F1 score. I got 72, and on the test set I have got 63%. The data set is small, and we tried to play with the data set a lot, but we couldn't do much because we don't know how to collect the data on this particular data set. We have got this data set from Kaggle, and just to show you an example of multi-label classification, we did this experimentation, whatever we showed you. Thank you.